The pace of change and growth in the development of data centers is significant. But how much scope is there to improve the sustainability credentials of their design and operation? Power usage is where big wins can be achieved. Clean, energy-efficient resources meet sustainability targets and reduce operational costs. But what about material choices in the design of these critical buildings? How do good intentions make it to reality? Is there an argument that design for manufacture and assembly, DFMA, could be adopted more widely by this sector? Putting the sustainability arguments to the test for this edition of The Scope, I'm joined by Vico Correas, a director with studioNWA, an architectural practice specializing in the design of data centers. Timo Hendy, a technical director in Stantec's civil and structural engineering team, working on both new build and retrofit of data centers. Andrade, a technical director for Suite Projects, a turnkey construction company with an extensive track record in data centers, and Stephen Meleady, an MEP director with Stantec and our lead on mission-critical facilities. I'm Graham Monday. Welcome to The Scope, a podcast from Stantec, a global leader in sustainable engineering, architecture, and environmental consulting. Timo, sustainability is at the forefront for data centers, and we've seen a lot of new ideas coming from the industry, but there's a long way to go. Where should we be focusing in terms of data center design? What's your 1, 2, 3, if you like?
Yeah, well, I mean, I guess there are three main areas, within data centers where you can find
efficiencies to bring.
You can make them more ecologically sound. One is, through the efficient building systems and the efficient technologies within the building that cool the IT equipment and keep the IT equipment running. And one is the power that then feeds those systems. Within these two areas, there are clearly the biggest wins as, they impact the operational carbon consumption of these buildings, which is where their biggest impact is felt. And then the source of power then is in the decarbonisation of the grid, which is, to a degree, not part of the remit of the data center provider themselves, and more about the wider grid.
And Stephen, we're seeing examples of that, aren't we?
Yeah, I think you're right. The MEP efficiency side has been widely interrogated in the past. I think there's a bit of a shift from a renewables perspective. I think historically there's been a lot of power purchaser agreements where people are looking at green PPAs, but certainly we're seeing more of a shift to people looking for sites close to renewable energy source generation, and clients are prioritizing that in terms of their site selection.
So efficiency of the systems, power, and Timo, the third one, embodied carbon, yes?
Yes, that's right. Yeah, and as a CSA designer on the design of the envelope of the building, obviously I would see this one as key, because this is the area where architects and structural engineers can have the biggest impact, because there isn't the obvious financial incentive there to deliver a low carbon building fabric. With efficient systems comes a saving on energy bills and a saving on consumed energy and operational costs to the building, whereas often with building fabric carbon saving, there's actually a cost to implementing these technologies, whether that's more innovative materials or other such ways of changing.
To be fair, it's perhaps a lack of understanding in the whole circle or the whole picture, in that ultimately it's either addressing it at the forefront of the design or is at the back end of the design via to say penalties, but it's carbon related charges. There is an opportunity for the industry to do more with regards to embodied carbon on early days, which can be a sale feature of the premise, a good sales point, and one that would go really well with their own clients or tenants or end users. It marries with all of the statements and aspirations as well.
And Roy, I was going to say, Roy, do you just come in here on this point?
Because ultimately, as we go to 2050, if we get to 2050, listening to the government announcements yesterday, we have to find how we cover our scope 3, and that scope 3 is currently being covered by offsetting, and that offsetting can be much lowered if we first consider what we construct our buildings from in the first place. So there is huge benefit for the future if we start now.
So Timo, I want to come on to some examples from yourself in a minute, but Anja, can I just explore just a little further for our audience here as well? Embodied carbon concepts come forward, but they don't necessarily make it to reality at the end. Is what we're saying.
There is an interest from clients. There is an interest from the industry on this topic, and so on designs, the embodied carbon gets looked at, gets measured, gets reported, but there is at present not many briefs will contain a section on embodied carbon as part of the design requirements, and so whilst the notion gets recorded in the packed design stage 2 or stage 3, or it went to planning with a certain metric, the design brief and the design scopes do not preclude delivering that target. And so at further stages 4 or 5, either because of VE or because of just losing focus of that as an opportunity, the results get diluted.
And Timo, before we come to your examples, and maybe you want to come in on this point, the question I'm going to ask is, how do we overcome that?
Yeah, I mean, I guess, it's incumbent on us, as the designers, and the area where we can really add value is by showing our clients that these technologies that we are putting in front of them can actually be that utopian unicorn thing that saves them money, saves them time, and saves material and carbon. And so the most effective ways that we found in delivering low carbon data centers is just by having very efficient design solutions, because they save on material. So the contractor and the client are happy from a monetary perspective. But that also then delivers massive carbon savings.
Have you got a couple of examples that you would like to share?
Yeah, for sure. Yeah. So we've, on a previous project, we saved 11,000 meters cubed of concrete from the design by making slabs thinner, reducing foundation sizes, which is, I think, something like 2,500 round trip flights to New York from London. And we've had two projects for the same client, where we saved 25% and 30% of steel respectively on the two projects. One of those projects was a project that included 4 buildings, and we could have built a fifth building with the amount of steel that we saved in the 4 that we built, which was quite a fun challenge to deliver. But the CO2 saving with saving all that steel is enormous, and the cost saving and time saving on site was also big. So it was a win-win and an easy sell for us to the client.
Okay, I mean, impressive results and impressive figures, and it's about educating and sharing that. Roy,
it is, and the thing that will hit the mark quickest is where we as designers can show cost and time savings. That will definitely affect the client's mindset. And these are the sort of things: building lean, building off-site, and building efficiently is where we can save our carbon. A lot of that has to come from there, but it does take the designers to take that leap of faith to do that, because there's some of the regulations that we have to build with or construct with does not make that easy. We have some very rigid legislation and regulations that makes that difficult for us at times.
Well, I mean, and in addition to the legislation, there are the end tenant requirements and their specifications, and they are sometimes unduly stringent and often don't get challenged by designers. So, some of the tenant loading requirements, for example, are misunderstood, miscommunicated, over the top, and that can lead to huge inefficiency in structural design, with much bigger member sizes than needed, and some of the tolerances and deflection criteria as well, which if we find an opportunity to flex those with the tenants, then by helping our clients to communicate that to the tenant, then we can find big savings that way.
Shall we talk about new materials? Because we've been talking about existing stuff. What are we seeing in terms of new materials coming through, and how easy is it for the designers in the industry to navigate this? Timo, maybe you can talk about timber, CLT.
Yeah, I mean, as ever, the US are leading the way here, and Microsoft have made a bit of a stir recently with their new CLT data center, which is definitely a really positive step forward and a huge opportunity for all of us to see that material used more, it's great and can be applied quite effectively. To this application. Some of the drawbacks with CLT is that it when you use concrete and steel together, they work together so the presence of the concrete reduces the amount of steel that you need without getting too technical. Sorry, but with CLT you can't do that as effectively, so you end up with more steel by using CLT. So there is a bit of a payoff there, but the overall carbon equation still works well for CLT. But I think that in recognizing that, we can see that there's possibly an opportunity to use CLT with steel in a different way to the way that we use concrete, so that you can reduce both the steel and the CLT, and no one's really doing that at the moment. And I think that would be an interesting thing to explore, structural systems that are designed around the use of steel and timber together.
In your world, Angela, how does this play out? What are some of the challenges?
I guess from our side, the challenges is that the industry tends to default to what they know. It's what they have used before, is what their insurers approve, is what it's also typically the requirements are very prescriptive, but occasionally on a project an alternative is permitted, and then and we have this example where a particular anti-blast wall forms part of the tenant's requirements in their description, but they have consented, and they have this precedent that they have consented something less onerous in another job, and so they would only accept that alternative, and they will not want to move from there. So it's very prescriptive. There is not a huge opportunity for new materials to break in. However, I think from an architectural point of view, the opportunity, and construction point of view, the opportunity is on DFMA. It's in the assembly of all of these existing materials, but into an off-site construction.
But I think there are opportunities in things like aggregates, the new aggregates that are being developed, the new cements that are being used, which are green credentials for those cements. I think they're a bit more expensive at the moment, but like everything else, the prices come down with utilization. And if we can actually get those specifications into our systems, I think we have more efficiencies coming in. So we have to be brave as designers and engineers. We have to be brave, and we have to put those things out there and see how we can further that effort by other industries.
Yeah, for sure. I mean, GGBS is cement replacement is part of our standard specification now, and we roll it out as much as possible on all data center sites that are within a reasonable distance of a source of GGBS, and that is a really great way of saving carbon in concrete. But there are new innovations in that arena, such as concretine, which is the impregnation of concrete with graphene, which then allows you to remove all the rebar from the concrete and reduces the cement content by even more than GGBS does. So these kind of technologies are burgeoning, and there's a risk associated with these new technologies that needs client buy-in to be able to actually deliver them on a project.
But we have to, as designers, put that model forward.
Yeah,
we have to dictate to the clients of what is acceptable in the modern world.
Okay, yeah, Roy, I'm glad you covered that point, which was going to be my question. How do we make this happen? And it's, by the sounds of things, as design engineers and architects, it's being braver to make the point and explain why. Now, Angela, you brought us on to DFMA a moment ago, design for manufacture and assembly. Let's just pick up on that point between you, and I don't know who wants to lead off on that, in terms of we see that in other parts of the built environment. Explain to me, with the complexities of data centers, how that could be used.
Oh, it's definitely a practice that can be implemented more broadly. There is a lot more than can be done. I think that there is progress in this area. I think we are perhaps victims of really rapid programs, really strict briefs, and perhaps not having enough opportunity to come. All of the changes that we're discussing require for, as Stephen said, for all the parties to sit around the table and come to with the ability to negotiate on those initial requirements. And in a lot of cases, that opportunity is not there during the design because the scope is given. There is no time. Simply, there is no time.
The swiftness of the build and is causing the challenge. Talk to me about other aspects of these sites where that it could still be deployed.
So I think we're seeing more of an uptake on it in other regions outside of the UK. I think we're seeing less in the UK. We're seeing other clients take it on. How they're taking advantage of that is a bit of foresight in terms of template designs and applying those template designs across sites.
Yes.
So they get ahead of the curve in terms of that program and that construction.
I think the most common application in the UK is in either services cassettes. So you see the services coming pre-assembled in a box that can then just be hung from the ceiling, and then packaged plant rooms and drivetrain units. So the drivetrain can be fully packaged and that's then bolted onto the side of the building. But what we don't see is DFMA within the actual building fabric. So within the building structure and what makes the floor plate and what have you. And I think that's a possible opportunity. I mean, the current limitation there, or the perceived limitation, I should say, is because the spans associated with data centers are quite long. You're talking clear spans of 8 meters by 12 meters, which is too large to have a single component that can be constructed off site to come in and serve that purpose. But if we were able to use DFMA systems that could be brought onto site, assembled on the floor and then erected, that would solve that issue. And I think one of the other key opportunities would be to integrate the secondary systems of the building with the primary systems. So at the moment, we construct a floor plate, which is the primary system, and then we hang from it a secondary frame from which all of the services are suspended. And those two things are independent from one another and don't help each other, and they both need their own independent strength in order to serve the building. Whereas in reality, if you were to bring them together into one DFMA unit, you would have something that's only doing the job once, so only using the material once. So it's a huge opportunity for efficiency.
Yeah, there's a huge opportunity there, particularly with some of the site locations that we're looking at in the UK outside the previous areas in industrial estates in and around London. We're seeing more remote sites where there's less local labour, skills, accommodation, and there's constraints on the site around not just getting operatives to the site or from the area, but providing them with accommodation in the area or transport to the site. So by providing off-site fabrication and commissioning and assembly, we're reducing that constraint and pressure on the site and making it a bit easier for the end client and the contractors to develop that plan for the site.
Yeah,
and that's where the benefits actually come in, because after you get to site, the amount of labour and the safety that you omit, or the risks of safety issues you omit by doing it in a factory, is incredible. So you have to see that as a benefit all round for the construction period.
And then there's the quality control and the reduction in material wastage.
Absolutely.
With the primary focus being on material saving. If you're not wasting anything, that's definitely a major benefit. And it lends itself so well to these types of buildings because they are, for the most part, a 10-meter cell that gets repeated 25 times. That's generally what the format is. So, and a lot of the vendors have their template cookie cutter design that they want to see implemented as much as possible. So that design's already ready before the project is in inception. So if we were to take these ideas and apply them to the cookie cutter before the project exists, then, we're ahead of the curve. The design is done.
Yeah.
Let's move on with the conversation in terms of what's on the horizon. What should people be thinking about? Roy, we've had a conversation previously about Scope 3 emissions, for example.
Well, the big challenge about sustainability and the net zero agenda now is everybody can say that Scope 1 and 2 is reasonably easy to achieve, and we should be achieving that quite comfortably. However, Scope 3 is the biggest issue. As a contractor, we've done a measurement of our own Scope 3 elements, and all of our works accounted for 99.4% was Scope 3. Now, that's our upstream Scope 3 will be the client's downstream Scope 3. And therefore, all of that carbon has to be offset at some point. So just imagine how many tons of carbon, if we move from the front end, can be saved at the back. It is huge. And we do need to consider Scope 3, which is not being widely addressed at the moment.
And some of the stuff we talked about was buildings being too heavy, maybe because of codes and things like that.
And this goes back to our point, as designers, we're very traditional. We base it on our regulations, our legislation, which is traditionally based on a solution that's already been predetermined. We've now got computer modeling softwares now that can actually bust that apart now, but yet we still go back to our traditional ways of construction. We should be using our modern ways of calculations and design to say, yes, that was traditional, but now we can prove that doesn't need to. But making the buildings lighter and therefore making it a lean construction build is definitely a huge potential for saving carbon.
Okay.
Yeah, definitely. And using less materials. I think it's, for example, when going through the planning process, perhaps this could be integrated even further. It gets reported, but when we look at design options, there could be merit in analyzing how they sit in the environment, how they contribute to the building, the building masses around them, etc. But also what additional carbon footprint will that building now contribute to in if delivered in that specific form. So
let's cover two other brief points then before we wrap here. Stephen, AI and liquid cooling was something we've talked about as well.
Yeah, I think we touched on earlier how there's been a lot more exploration around efficiencies from an MEP perspective, but I think there's still opportunity there with some of the changing technology. So obviously high density racks are creating much more of a demand for liquid cooling within the space, and that creates some opportunities to move from historically a air-cooled system to a 75% liquid-cooled system in the current arrangement. So there's opportunity to eliminate some of the efficiencies associated with fan systems and the medium of cooling via air. So there's definitely opportunity moving forward to reduce the energy usage.
And can I just add on that, because we go into liquid cooling and the chips are able to accommodate higher temperatures, we got higher off temperatures from those chips, and therefore those higher off temperatures will assist us in our district heating plans, because at the moment the temperatures that we get is pretty mundane, but if we can get another 5-10 degrees out of those chips, it makes a huge effort to offsetting that.
Yeah, we've seen a historical shift from like 6-12 degrees all the way to what we're seeing now, which is 25-30, which opens up the door for more opportunity.
And that's going to go higher, I think.
Yeah.
And Angela, is there a brief moment here just to ask about district heating as well and the opportunity for that?
Yes, well, I think as we're saying, there's huge potential to that idea. I think we all know this is still in the real, or lives in the realm of ideas here in the UK, whilst it is realized in other areas of Europe, especially Northern Europe. They seem to have gotten a good grip to the system, but over here at the moment is still in the realm of ideas. Either it would entail district heating systems, which is obviously a much more complicated notion, or this would require perhaps a bigger nudge from the planning authorities towards private agreements between perhaps the residential and the industrial sectors.
Yeah, I'm quite interested to see with the government's new AI growth zones and the plans they have to co-locate these data centers in one area, what's going to happen from a heat export perspective, and what ideas they have around that, and what other building uses that they can put in those spaces to ensure that we're going to take advantage of that.
And as a country, we do lack the infrastructure to get that distributed, and that has to come from central in a lot of cases, or you have to be incredibly lucky and find a heat consumer on your doorstep.
Timing.
It's a huge timing problem.
Yeah.
So that's a big opportunity, isn't it, which requires more focus, more probably, and sponsorship from central government. But what I've heard from this conversation today is there's a lot of other things that, with confidence from the engineers in terms of designers and the architects, pushing solutions to clients and to operators and to developers, can also help to ensure that this sector is as vibrant as it is in the UK, but also very sustainable as well. Okay, thank you. Really good debate. Thank you. Thank you particularly to our guests, Angela from studioNWA and Roy from Suites. Thank you as well to Timo and Stephen for joining us too. Thank you for listening. If you've enjoyed this episode, make sure you subscribe to The Scope on Apple, Spotify, or wherever else you get your podcasts from. And you can find all of our episodes on the Stantec website.